Hello, and this is AP Computer Science A with John Maxwell, and today we're going to go over some basic print examples. We're going to go through declaring variables. We'll also use those variables to perform arithmetic operations. We'll also look at compound operators and how to input values in from the keyboard. So we'll start with the print example, and the goal here is to learn the difference between println and print and understand some of the nuances. You can see in line 4 I use the println command. This command puts a carriage return after the output because ln perhaps refers to line, indicating there'll be a new line after the output. Line 5 has the command print, which does not put a carriage return after the output, and so in line 6 it will be followed by see what I mean. And so I'll run it to show you what it does. Okay, this command puts a carriage return after the output, referring to print ln. This command does not put a carriage return after the output, referring to line 5 in the print statement. And so the succeeding statement, see what I mean, using print ln, appears directly after the output of the print statement. So, summarize, ln puts a carriage return after the output and print does not. Now in line 8 and 9 we have a unique example that you have to be aware of. We're using the plus sign in two ways, one for addition and the other to join what what is the string, right? What is the output? And in line 8, we reverse the order. And so you can see that 5, what is the output, is appearing when 2 plus 3 occurs before the string. However, what is the output when it occurs after the string will be 23. And the reason why is Java and the compiler work from left to right, and so when it sees 2 and 3, it correctly identifies that both sides of the plus sign, the right and the left, are addition, are numbers, and it'll perform addition. And then later join the string to the result of the addition. On line 9, it's first what is the output plus 2. And so the fact that it's a string added to a number overrides the fact that it's a number at all, and regards the whole operation as a string, and then adds 3 to the end. And so you see what is the output 2 plus 3, which is what is the output 23 on line 9. You can easily correct this with parentheses to force an operation before another, but you do need to know, and these things are testable on the AP exam. So we're going to cut over to declaring variables in another program, and I'll point out here that we have a class first declares an integer, which is a whole number, and it reassigns the value in the second line on line 6, a equal 15. We also have a double B, which is a floating point number or a number with a decimal. We have Boolean game over, which is set to false, and char letter equal y in single quotes. Notice chars are in single quotes, strings are in double quotes. And so I basically have declared these variables known as primitive data types, and we'll run this program to see what it looks like. Okay, so basically I'm setting up variables. Variables are the essential part of a program because variables hold the data that the program is going to work with. And so One thing about Java is that you do have to declare what type it is, and we'll go a little bit further into the differences in types, but the most common are int, which holds a whole number, that without a decimal point, and double contains a floating point number, and that is a number with a decimal point. The Boolean holds a true or a false, that's it, and char letter holds an individual character, typically in the alphabet. So those are the basic four types. You may have read about others: shorts, longs, floats, etc. The College Board does not include those types on the exam. Next, we move over to arithmetic using variables. And I take the very same variables, 10, 6, and 17.7, and I'm going to perform some math with them. And first we have addition, a plus b, and subtraction, a minus b, and multiplication, which is a times b using the asterisk sign, division, which is a divided by b, and modulus, which is a percentage sign b, the percentage sign referring to the modulus operator. Okay, so we're going to look at that and talk about it for a second in isolation. We'll run it and ignore the end part, but addition, 10 plus 6 is 16. Subtraction, 10 minus 6 is 4. 10 times 6 is 60. However, when we divide a by b, we get a result of 1. And that is because 6 only goes into 10 one time. Modulus returns the remainder, which is 4. So you may ask yourself, what's the use of that, having a division that doesn't report the result accurately? Well, it's used in a number of applications, and one of them would be time. If you had 80 minutes, that would be 1 hour, the result of division, and 20 minutes, the result of the modulus. So in applications like time and many others, the modulus operator comes in handy. So you always have to beware of integer division. It is a sneaky topic that is tested throughout the course and on the exam, and you need to beware. Whenever you have two ints involved in division, it's only going to return the number of times the divisor goes into the numerator wholly. So most operations involving a double would result in a double outcome, and that is the case. But beware, like a divided by b, as we just talked about, would be 1. 1 plus c would be 18.7. So if you wanted something differently there, you would have to work on trying to solve that problem, which we're going to solve in a program or two. You're thinking PEMDAS, right? And please insert the M for modulus in the middle of M and D, because it's on the same street, has the same priority as division and multiplication. So in an operation that moves from left to right, beware that modulus could be done first if it's the leftmost calculation. Now, to raise to a power is just not straight out easy in Java. We use a library called math, and down at the bottom we can see math.pow a 10 to the second power b. And so we raised that to 10 squared, and that's 100. Taking the square root of a, which you can only do with a positive number, you get 3.1627, a really long number. Okay, you may find yourself interested in rounding. So if we round that double, which is 17.7, we raise up to 18. And so I just want to repeat my warning about modulus. It's only between two integers, and it returns the remainder of integer division. Integer division and modulus are the areas on which you need to be concerned, because it doesn't operate like you would be plugging those numbers into a calculator. So what we're going to move over with, now having covered the plus, the minus, the asterisk, and the division, as well as the modulus, are compound operators. So this is pretty simple. A equal 5, A plus equal 5, and you also have minus equal, star equal, divided by equal, and percentage equal. These shorten expressions, and so let's look at it. Well, obviously it adds 5 plus 5, and the value is 10. So what it's saying is equivalent to A equal A plus 5. So you can write it either way, but you're going to see compound operators throughout the course. And so you need to recognize them even if you write it out the longhand way. By the way, A equal A plus 5, it's not an equation indicating that both sides on the equal side are the similar value. Basically, we refer to the equal sign as an assignment operator, and you may guess that the equal sign has a pretty low priority done after all the arithmetic operations are done, in almost all but the most weird case of all. So that's compound operators, and you should be able to get a hold of that. And finally, we have we have two more things. Casting. Okay, casting is when you change the type, either an int or a double, to another type temporarily. And so, here's the example. The grade total is 127. All the students combined to have a gross score of 127. And the number of students was 10, and the average starts off at 0. And so if I take the grade total and the students and output the average, I'm going to fall victim to integer division. 127 divided by 10 is 12. However, in this statement, I cast grade total to a double temporarily and then divide by the number of students. And so watch what happens. Okay, I'd rather have an average of 12.7 than an average of 12. And so beware integer division. When division is formed between two ints, it will lead to a result, which is the number of times the divider goes wholly into the numerator, and so the answer would be 12. However, if we want a more accurate average in this case, we will use double to cast grade total before it gets divided by number of students, and we get the proper result, 12.7. Again, casting can go either way. If you cast a double to an int, you'll probably get people screaming at you because it'll tell you you're losing precision. You're losing precision. And if you cast a double to an int, for example, you'll end up with 12. Okay, so, you'll end up with the fractional part being discarded. So that's casting, the temporary changing of a type of variable to another type for the purpose of more accurate calculations. You'll see casting throughout the class. And then lastly, we have int min max. So here I do something which is on line 1 to import a library called scanner. And scanner is built into the Java language. However, you do need to import it. It doesn't come in naturally. And you can see it's part of the Java utility grouping. And on line 4, I create a new scanner class object called in. I named it in, and that's just pretty standard. Scannered in equal new scanner system dot in. As we move into classes, we will understand the new keyword and what's going on with classes, but for now we'll just look at that. I prompt the user for input, enter an integer, and then the scanner in.nextInt will pull in the scanner from the keyboard. Prompting for a double, the scanner in line 8 will take the input, which is hopefully a double, and store it in B. I'm gonna output A and B just to prove that like they've gotten into the program and you're able to use them. And finally, the last group of 4 statements refer to the maximum and min value that an integer can hold, as well as the max double and the min double. So it may surprise some people, but the numbers that can be represented in a computer are not infinite. They're bound by hardware and system limitations. You just don't have that many wires to express a big number. So there are solutions and workarounds, classes and things like that that allow you to go a little bit bigger, but it becomes a little bit more difficult. And when you're dealing with things like world population or astronomical different distances to a particular star, you're going to have trouble representing them using the traditional primitive data types int and double. So let's take a look at what this is. Okay, so it's asking me to enter an integer, and rather than type up above, I'm just going to type 12. Okay, it's my favorite integer. Enter in a double, 2.3. And 12 and 2.3 are outputted, but notice the maximum integer and the minimum integer. They're actually quite small. I'm not sure you can represent the population of the world in that. And the max double and the min double. Students always ask me, since min seems so limited, like look at that, max double and min double, why do we bother not using them? Why don't we just use doubles? And so I conclude this lesson on primitive data types and the operations involved by simply saying, when you have an opportunity to decide what data type it is, choose the truest form. So there's no half humans, so it's an int population. And you just have to be aware of the upper end of it. And then if you reach the upper end, it's time to use some of the other solutions. However, in most of our examples, we're just going to be working with small numbers. And so this is just a caveat for your future self that watch out for the max and min values of the primitive data types. Well, this has been a summary of AP Computer Science A, variables, operations, printing, casting, and inputting. My name is John Maxwell. Until next time.